Hello and welcome back. You're watching TestDive, the conference organized by Nokia and aimed at testers. And I think we're ready for our next speaker. This time, this is going to be Julio Cesar Fort. Now, Julio currently works as partner and director of services in Blaze Information Security, a company providing cybersecurity assurance services to corporate customers and startups in Europe and South America. Now, he's been involved in IT security one way or another for as long as he can remember. He holds a master's degree in information security from Royal Holloway University of London. Now, Julio started working in IT security after he realized that he could actually get paid for what he used to do for free, which is hack other people's computers. Now, Julio, so the cyberspace is now open for your hacks or your talk. I don't know, whichever you prefer. Anyway, off you go.
Okay, so thank you very much for the warm introduction, and thanks again for having me here. So, yeah, our presentation today will be briefly speaking about application security testing in the age of agile development. So yeah, a quick introduction about myself, from me this time. I'm currently working as Director of Professional Services at Blaze Information Security. We are a company providing mostly technical application security services and penetration testing for corporate customers in Europe and South America. So, well, let's move on, talk about briefly the agenda of what we're going to be speaking today. So we start the presentation by speaking about the traditional penetration testing model and why, at least in my opinion, it is kind of broken and not necessarily fit for the purpose of this day and age of software development methodologies. Later on, we move and talk about a few modern initiatives related to application security engineering, and we try to at least come up with an answer for the question of how can QA testers help in offloading some of the work of the security team, and also finding bugs, security bugs themselves. And finally, we conclude the talk. So let's talk about the traditional penetration testing model and its problems. So we all know, you know much better than I do. I do not really have the development background that I would like to have. But in the past decade or so, there was this shift from, maybe even more than the past decade, but there was this shift from waterfall to agile development model. So we went to all these things with agile and DevOps and so on. But unfortunately, once again, security was left out. If you see all the agile manifestos and all those documents and so on, there is very little to no mention whatsoever of the importance of application security. And unfortunately, once again, application security did not really take the driver's seat on that one. So just a quick recap of the waterfall development process. This is kind of the old school way to do that. We have the requirements and use cases, architecture and design, test plans, code, tests and test results, and finally the deployment and feedback, which means that all the software is ready and it's in production. So this old model, there were multiple attempts, especially by Microsoft and a few firms that used this model back then, to sprinkle around it a few security initiatives that we're going to see later on in this particular model. But then okay, we moved on now to Agile, that it's at least, well, I'll say my opinion of a person that doesn't really work as a software developer or a tester, that it seems to me at least that both Agile and DevOps, they are essentially what waterfall is. However, in many interactions throughout the development of the system, and in much shorter cycles, which means that we do all that waterfall thing in sprints of a week or 2 weeks or or 4 weeks or something like that. So it's as if, at least my impression, that we have multiple waterfalls and waterfalls and waterfalls until the software is actually ready. So um, all of this, I wanted to actually speak about this, what I believe is a problematic approach to security. Again, as I said, none of these methodologies, they actually talk much about security. But the problematic approach that I want to speak about is that if you think of your system, like of the application or something that you're developing as a cake, so security is often brushed on top of it. So just just like cream or cherry on top of the cake, instead of being baked into this cake, which means that we do not really have security in the very foundations of our system, or in this case, our cake. And because of that, in my opinion, it we are creating like it's actually an inherently more insecure system because, well, first of all, it never really had any security activities, or it was never really designed with security in mind from ground up. And this attempt to retrofit security, just like brushing on security on top of it, uh, it uh, it has a lot of problems that we'll see later. Another problematic approach to security, especially in this day of DevOps, Agile, and so on. So we are pushing code continuously. So in many organizations, even we have code being pushed like dozens of times per day, even hundreds of times per day. Some of them less, but still you are all the time like producing new code, testing new code, and pushing out to production. But yeah, you're always releasing code all the time. But are your security initiative also continuous, just like your code like that's being continuously deployed? So now talking about the traditional security testing model that most organizations, at least the ones that do have any sort of security activities, what they do. So the traditional security testing model, it's something that it was probably defined by the U.S. Air Force. Like they were commissioning penetration testing. I think like this is probably one of the first usage of this name of some old computer systems they had, in the 60s. And then this was picking up momentum, especially in the 90s when the internet became a thing. There was like a boom of internet and the usage of personal computers and so on. They were becoming more ubiquitous, and all of this sprung up an entire industry of IT security testing. And it has the same it's the very same shape and form that we have from the 60s, and even from the from the 90s, and even from the 60s. It's pretty much the very same thing. So it means that we are doing the very same uh, security testing, like in the very same way that didn't really change that much for the past 30 years, or if you want to stretch, some 60 years even. So what happens is that this traditional way is that it's taking into account like the more waterfall based kind of things. That security testing only happens in the end of the process. So everything has been already built, and you bring in a team, whether external or like your internal security team, if you have one, to reveal and to break things. But then again, this doesn't really fly that well, right? Especially when it comes to the continuous development, the continuous like pushing out of code that we have these days. And also, in many cases, these like time box engagements. Usually, a team gets hired for a couple of days or a couple of weeks for an assessment, and it actually makes it quite hard to get acquainted with the inner workings of the system and get the best bugs out of it. So yeah, there will be a gap probably in what going to be discovered. So it's actually from what I said, like it's pretty clear that there's like a couple of disadvantages to this approach. So one of the thing is it may delay your go live date. And because, well, like, what if things are really broken? Then you get like your security testing report from a third party or an internal team, and then you see, well, like, plenty of security vulnerabilities that are too much of a risk for this to go live, and we have to patch this as soon as we can. And some issues are actually more complicated to fix than others, especially when you have like design issues and so on. That's actually going to be far more complicated to fix. And then it will be up to you to either accept the risk and go live, or just delay your go live date for, well, to fix the problems before they get on production. And it was also like clear that from what I said before is that trying to bolt on security into software that was already developed produces an insufficiently secure product. And most importantly, the cost of fixing this issue, they gradually increase as the timeline of the development of the process happens, as we'll see in the next slide. So this is was a research paper from IBM Rational from, I think, like 2008. So it's kind of slightly dated, but it seems that still makes a lot of sense. That it says that it can cost up to 30 times more to, like, in terms of costs, to fix defects in a product. By defects, I mean whether like functional bugs or security issues. That more importantly, at least for my talk, that they can cost up to 30 times more. Sorry, when the system is already on production, so when it's already released, than it would have cost in the very early beginning of the development phase. So another disadvantage is this silo culture that we have. I mean, considering that we still have, like, this old model that you have like a testing team that's completely separate from development team, doesn't really have this good synergy. Is whoever's testing, or like in this case, whoever's trying to break the system, they often lack the knowledge, like the internal knowledge that the builder or like people that are more ingrained with the team will have. And there's like a bigger chance that this will miss some edge cases and more tricky bugs and some logic, like business logic based vulnerabilities that might be missed because of that. And as I mentioned actually before, security becomes a bottleneck for faster release. So this is like an anti-pattern, right, of what we have, especially with DevOps. So now let's talk about some modern security engineering activities in software development. So at least from my experience, like working with like a few development teams, we are seeing that some of them are actually more concerned now into building security in, like since the very beginning, the foundations of the systems and platforms they are developing. As by this, they're making this by bringing in a few security activities as active part of the sprint. Like, for example, to have when the team is crafting the user stories, there is always someone thinking in a more adversarial way and creating abuse stories, for example. So all of this actually helps to improve the overall resilience of the system, because what you're going to be start building it with security in mind since the very beginning. Again, the quick recap of the waterfall, as I said, like what has been tried to do like in the past. As for requirements and use cases, people were coming up with security requirements, abuse cases. As for architecture and design, risk analysis, threat modeling, these are like very important. Actually, in my opinion, these are like some of the most important of the activities that you can have in your product. Sorry, in your project. The task plans, like creating security-oriented tests, like code review, and then task results, like more when penetration testing vulnerability scanning was happening, and of course, like deployment feedback, like the DevSecOps and the continuous pen tests. But yeah, again, like this was a quick recap of the waterfall. Like if we like see this as like water, like kind of agile being kind of smaller waterfalls, it's like more or less things that would happen. But then again, this is like in the ideal world, what we would have is like developer training, some general security consultancy, threat modeling in each sprint, or at least something that could be more like offloaded also to the teams, to developers. Source code review from a security-oriented standpoint. DevSecOps, like your ops team, also like helping you with that, and penetration testing, at least in every major release. But then again, this is the ideal world. Let's talk about the real world. Like the real world, like with a lot of luck, you might get one penetration test here, and this is going to be maybe something like once a year, or just because a customer or like an investor or something told you so, that yeah, you need to do a penetration test. We need to have some degree of security assurance of the system, of the platform that you're producing. But then in many cases, this is actually instigated by outside partners because they want to avoid the third party risk. And this is usually, again, only once a year, which means that you have pushed out code into production like hundreds, maybe thousands of times in the entire year. So you have a massive gap of 1 year. Again, you're going to get another security test. So what does it mean? That maybe the whole year of code that you wrote could have introduced some new security defects. The trying to answer the question, so how you QA testers can help, and also like developers as well. How can we help an average team with little to no like security resources to improve the security maturity? Well, as for ops, that's actually important because again, everybody's now working together, right? There is not much of a separation, or at least not should be, not the way it should be, to have this big separation of between teams. Your ops teams can definitely help by adding some open source security checks in your DevOps pipeline, and making it like more like a DevSecOps thing. Your security team, this is actually the probably the main takeaway of this talk, is that in my impression, in my opinion, is that the security team, if you have one, or if you don't have one, maybe it's important to, well, pay it like a security oriented training for your QA team to teach the application security basics, like really one-on-one, or at least how to identify easy bugs and the quick wins. My opinion with that is that a lot of the issues that we find during penetration testing and security testing and so on, they're actually, a lot of them are actually quite easy to find. A lot of them, it's something that could have been found in the QA part of things. And the idea is to offload some of these issues that can be found in QA for QA, and then leave the security team that is usually a more specialized in a way that is not that we are testing like on a regular basis, right? So just leave them with well, to find the edge cases, the more tricky bugs, because that would definitely like speed things up when it comes to security. And even that, if you don't have a security team like dedicated one, at least you can like squash some of these bugs in your QA process. Let's talk about the first quick win, cross-site scripting. Cross-site scripting is an attack that can, well, compromise users of a website. It's more like a client-side kind of attack. So what happens is you can, for example, enter like a malicious payload into a field that this will cause the whoever is visiting this website later on to have this code that you injected into it being reflected to them or being executed on the user's browsers. And this is, I would say, like the most common, probably the easiest one to, I mean, and it's still very prevalent, actually. I've heard of cross-site scripting first time 2002, and we are almost 20 years later, and this is something that it's found actually on a daily basis. Again, this is like one of the most common classes of vulnerability affecting web applications. And as a simple payload here, how to test. This is like one of the hundreds of thousands of payloads actually that can be used. So let's see a quick demo here. Let's hope that the demo gods will actually be on our side today. So This is a blog, like a kind of a blog application variable that I created especially for this presentation. It's all written in Flask, and so let's create like a test dive hello, and like we injecting some HTML code here. Let's inject something else, like the alert box here, and the author. Well, let's do something else. Example. And let's post this. Well, so we see it just popped the alert box, which means that whatever I just introduced there, it's actually being reflected back to me as a user, as like that code is actually being now executed on my browser. Again, like so, all those fields are not properly sanitizing the user input. And you can see here, well, it's kind of broken and like with some HTML, like I mean the H1 tags here, for example. So it means that whatever like scripts or HTML that was injected there is actually just being echoed back or sent back to the user without any sort of sanitization. So this is a problem because you can actually execute JavaScript or any like that can be also like malicious scripts to, for example, steal session cookies and things like that. So let me just close this one. Let's go back to the quick win number 2. It's called template injection. So template injection usually happens when the user input is injected into a template rendered by the template engine as such. So template rendering is usually executed in server side. So a simple payload here that we have is the brace 7x7 brace. Again, brace because I'm using like this like Ginger 2. So like depending on the template engine that you have, you might have a different syntax. So you have to take this, of course, into consideration when you're doing your testing. So it means that this times, like sorry, 7x7, this calculation that goes into 49. So it means that if we inject this data, this payload somewhere, and if the response is actually 7x7, like 49, means that it was actually evaluated on the server side, and which means that, well, we can probably, most likely, we have a template injection issue. And then this can actually even escalate up to remote code execution and actually well, like with template injection, you can actually do like far more than just like calculation like that. You can, like, for example, use like introspection and like see like the variables and configurations and so on of the application. So it actually it's pretty problematic because unlike cross-site scripting, this particular case is actually server side. So you can actually, there is like a possibility that you can actually compromise the server with that. So let's see here another example. We have here, hello world Julio. So this field here is vulnerable. So let's dive. Hope everybody can see this. So yeah, if you see here, the payload that I just put, like 7x7, it means that's being evaluated on the server side. So, well, like seems like we have one like template injection here. Let's move on to the third quick win. So IDOR, insecure direct object reference, it occurs when user input is used to access objects directly. So this is like a very common access control issues. And to be fair, this type of issue is usually very easy to find. So for example, when you have in your website or, like an application, you see something, something ID equals 1. So what happens if you put ID equals 2, ID equals 3, 4, 5, 1000, and you just cycle through all of those IDs, or like provided they are actually predictable? What actually happens with that? So in many cases, you actually are able to uh, access these resources directly by forcing the application to browse to them, even though in many cases they were not supposed to be seen by you. So let's see another example here. So in this application here, as we saw, you can create posts that they are actually private. So we see here all public posts are being displayed. So this is a public post, another public post, a little test dive, test again. These are all public posts. So these start with one, okay. Starts with 3. It's like the first one that's public. But how about post number 1? Okay, doesn't exist. How about 2? Well, a private post that had some secret information here. 4, iterate through this. Okay, 5 doesn't exist. 6, well, it does exist. It's actually public. This is another um, secret post. So of course, we don't want to go through this manually. We could use Burp Suite. This is like one of the tools that we use when we're performing penetration testing. So what we could do here is that we can just send it to Burp Intruder. Let's. So it means that, let me. So what we just instructing, I mean, it may sound like a bit strange, but what we're just doing is using this tool to tell it to send all these requests, like from to cycle through, like this is the placeholder. So payload type numbers from 0 to 999, each one step. So let's see if, I hope nothing breaks. Yeah, and then we see here the status code. So we see like a bunch of them are actually 200. So a bunch of them actually we could access. Some of them actually 404, they don't really exist. And these might include some private data, for example, like some private ones that we saw before. Let's go to the other quick win. That will do this like server-side request forgery. So in the case of server-side request forgery, it allows an attacker to instruct the application to issue requests on his or her behalf. We are talking about here only HTTP. Like, I mean, there is like some tricky ways to smuggle other protocols through SSRF, but it's not really our focus here. So think about it. If you can instruct the particular application to actually make a connection on your behalf, and maybe it's fetching some data and sending back to you as kind of a proxy kind of thing. It means that you can also instruct it. In many cases, it may be able for you to instruct it to connect to an internal resource, like past the network, in the internal network, like past the corporate firewall, for example, which means that you may be able to interact with other like inaccessible like back-end systems that you were not supposed to. And the result of successful SSRF, it can range from like everything from leaking like cloud secrets sometimes, and even code execution in more extreme cases. How to test? Like, I don't know, if you see a parameter taking a URL, if you put like in this case, my IP is, this is like a website that will tell you this is your IP address or something like this. If the IP is not yours, but the server's IP or something else, like means that, well, another, it's actually someone else, like a server or application or something, doing this request for you. So you might have an SSRF. Of course, there are like different ways to test for this, like more reliable ways as well. We use like Burp, like Suite, again, that tool has something called Burp Collaborator. That Burp Collaborator, it will catch different interactions, not only the HTTP interactions, but also DNS queries that a server, like in this case of SSRF, will have to do the DNS lookup, right? So it will connect there, or it has also like SMTP and a few other protocols that it can tell when these interactions happen. But yeah, let's see how this quick win actually can be done. So you have here like something trivial. Let's see, blaze of sec. So yeah, it just got the website, right? But then what if I put some localhost, let's say port 1234. Nothing really breaks, but let's see how it goes. Okay, an error, which means that most likely might mean that the port's closed and so on. Let's see again with this port 888. Okay, well, it seems that I managed to actually see directory listing for something that, well, secret.txt. Okay, great. Let's have a look what it is maybe there. Oh, okay, well, it's a secret file. It's just to illustrate the fact that if you can instruct the server to make requests on your behalf, and even better, if these requests are actually being returned to you, great. Like you have a SSRF, you might be able to scan the internal network, you might be able to connect to some servers or services that do not have authentication, things like Redis and so on. So and then, well, it's actually more tricky to actually pull off an exploit when it comes to some cases like that, but it's just like an easy way to illustrate on how to find uh, these quick win issues. The next one, misconfigure authorization. So the idea of authorization is to allow or restrict access to a given resource, right? We have this concept of horizontal and vertical privilege escalation, so I think it's important to explain this difference. So a horizontal privilege escalation means that you have user A and user B, and user A and B, they are of the same role. For example, they are regular users. So I can see me as user A, I can see my own data and say my own posts, in this case of a blog. And the user B can see their own data, they can change their own password, for example, and they can see their own blog posts. But a privilege escalation horizontal means that user A will be able to see the resources of user B because they're in the same level due to a misconfigured authorization. In a vertical one, it follows a similar idea. However, vertical, you can see you as a regular user can access users that are on a level above, like for example, an administrator. So you can actually access resources that were only to that should be only accessible for users with higher privilege level. And a very easy way to test, to get two sessions from different users, in this case, user A and B. Try to use user A's session tokens to access the very same resources that are expected only to be available for user B. If you're actually able to access one of these resources, it means that you might have a misconfigured authorization. So let's see here a quick, um, let's have a quick look at this. So we have here, this is like a regular user, test222, like just for the sake of our explanation here. And then I have an admin user. So what I'm doing here, using this strategy that we just talked about, get both cookies, uh, the cookies from the low privileged user and of the high privileged user. So actually, this is the low privileged user one. And then again, like using Burp Suite could be anything else really. But then like Burp, actually this plugin for Burp called Authorize makes it pretty easy to do that. So what I'm doing here is I'm proxying my browser here, like in this case Firefox, with Burp. So all my traffic's being proxied into that. And every time it's seeing the cookie session and so on, like of my session here in the browser, it will also replace for like a copy of that same request. It will also replace it with the cookie of the low privileged user, which means I'll be just browsing the application normally. Like for example, click here to edit a user. I'll just be like browsing the application, just doing like my regular thing. Like a user, oh, actually doesn't exist. But then it will tell me like some of these authorization status have been bypassed or not. So let's say here. So well, this means like a bypassed one. So it means that even as a regular user, so we can see here, I cannot really access the admin page as a regular user, but if I force accessing it, oops, sorry, if I force access it with the like with this like user view and so on, actually this allows me to do so, which means that this authorization check is not really being properly done on the like in the application in the code. So the idea again is very simple. You get you usually that's what I do is like I browse the application with like either higher privileged um, profile like a user account, just browse it like normally and so on, but then put it like in this case using authorize to use the also like make a copy of this request with the cookies of a lower privileged one. And if the responses are actually the same, it means that these authorization checks are being flawed. So yeah, the conclusion. So like, I mean, the main takeaway is I understand like what I did here is like very manual and so on. I understand, especially with like agile DevOps teams, a lot of testing is actually done completely automated, which is like a good thing. Like I can understand, like it's actually may make it feasible to do like manual tests. Always like in this case that you're always pushing code into production all the time and so on. But the idea here is to actually to show that some of these issues they're actually quite easy to be discovered. Okay, they are very easy to be discovered, and then you can actually codify it into your. Well, you can actually codify it into your test cases, and also whenever if you like, I understand it's like might be an anti-pattern for agile, but if you have manual tests, it's actually something that you could uh, also incorporate into that. I have a critic about DevSecOps, like a little bit, like so, like people believe this is actually a silver bullet that you just put like a bunch of automate tools to check into your pipeline and then your code secure. Not really. There's like a massive gap of what automated tools, like fully automated, can discover and what manual tests, in this case, like more like manual exploratory test, will be able to find. But then again, like like the main takeaway is more like this is actually not so difficult, and you can actually codify it into your unit tests and your to another type of tests that you have. So remember, security is not always that complicated. Thinking these ways make it harder. Like people like to romanticize it, like with Mr. Robot and so on. Actually, anyone can do it. Like it just takes like a little like study and perseverance for that, just like anything else in this world. Code is being pushed into production faster than ever before, but security didn't catch up. But yeah, we're trying to make this change. Introducing this into DevSecOps pipeline, it may give good results again, but it's not a silver bullet. It's not something that I'll just put like a bunch of like automated scanners here and it's going to detect everything. Not really, especially some of these issues that we've just showed here. They're easy to discover like when we're doing it manually, but some of them scanners are not that great at picking up. And again, like a lot of like my security friends will probably don't like the this statement that I'm saying now, but a lot of application security testing, in my opinion, is just glorified QA with different names, different tools and hacker sounding names. That just like we saw like Burp Suite and so on, like some tools are actually more suitable for us doing this kind of tests. And I think like any application security 101 should like educate developers and QA testers in how to use these tools as well. And the main takeaway as well is that with the Agile, like security is now part of everyone's job. It's no longer just a thing of a security team. It's something from developers, from ops, from product owners, from like testers. Like everybody has to be involved. We are all in the same boat when it comes to these. To the need of creating like more robust and resilient systems when it comes to security. And that's all for today. Thank you very much. If you have any questions, like just catch me on Discord.
Yes, Julio, thank you so much. Fantastic talk. Thank you very much for delivering it. Yes, the space is now open for questions. So if you'd like to ask a question, please do type one in into our Discord system. Let me just pick up on what you said in the conclusion, Julio. So you said that on the one hand, testing is not that difficult sometimes, and also there's a lot of automation going on. Do I understand correctly that it means less work for testers in the future or less employment, or does it mean that people will just need to reskill in a sense? And again, it will be still very popular as it is today.
No, I think like it will definitely be popular. Again, like I said, like there's a lot of automation going on. But then, I mean, first of all, like it needs people actually to write the automations, right? But then I don't think there will be any decrease on that. I do believe that yes, like people will probably have to skill up, especially when it comes to. I believe that some part of security testing will. There is this whole movement on shift left and so on, also with security. So a lot of security testing is actually now, like in some organizations, is going to becoming like a responsibility of the developers and QAs as well. So I think that people will have to skill up in order to become like more relevant in the market in the future.
Okay, lovely. Thank you very much. And now one question from our audience. And the question is, which open source tools would you suggest as a starting point for DevSecOps?
Well, like it really depends on what you're doing when it comes to DevSecOps, right? Like, so what happens is that you sometimes like I don't know you can have scanner security like sorry not scanner container security. So there's like a few different tools for that, but like in the case that we're talking about here, application security, a lot of people suggest Zap or ASP Zap. I particularly hate it. Like I don't think that anybody should be using it, to be fair, but it's open source, so it doesn't really cost much, and you can actually do like some automation with it, which is a good thing. However, if I would suggest, like if you could afford like a proprietary tool, Burp Suite is definitely the way to go. But yeah, as for like to get your feet like wet, like test the waters, I think Zap is a good one. But to be fair, if you're professionally doing it, I don't think I really think it's actually pretty painful to use. There would be like other tools as well. Like there's like I think Arachne that does some automated like web scanning. It works quite well. If you're developing like a mobile application, like MobSF can be one as well that you can actually integrate into your CI/CD pipeline. What else? Well, it really depends on what you're developing and what you're trying to test for. But there are like multiple tools for this one. So yeah, I would leave like Zap, MobSF for mobile. I think Aqua has probably like some open source versions for that you can actually use for container scanning. Well, like so many really, but yeah, Zap's probably the way to go when it comes to open source. But if you can afford, go for Burp, because I don't know anybody that professionally uses Zap for actually, I mean, doing any professional work.
Okay, lovely, thank you. And one more question from the audience. What about credentials used in production in continuous integration? Which are the changes, or what are which are changed at the end of production? So let me rephrase it again. So what about credential used in production in continuous integration, which are changed at the end of the production?
Well, I don't really think I got the question entirely, but it's more like hard-coded credentials in a code or something like this. Is this like the question?
I'm not entirely sure what the author is referring to.
Yeah, I didn't really understand, but like, I mean, if this is what I understood, there are also like a couple, yeah, actually, a few things that you can actually have some, like some tools like Truffle Hog, for example, you can actually have on your CI/CD pipeline that it will prevent code to be committed with credentials and secrets and keys into like into production, for example, into your repository. It will flag kind of, oh, you're trying to commit like some hard coded secrets, keys, and whatnot into your code. So if this is actually the question, there's like some ways to prevent this from happening, like automated, and this actually works pretty well, and you can do it like open source.
Okay, perfect. And one more, and I think also maybe a difficult question. How would you approach sec test in CI or CD for SaaS in microservice infrastructure? Staging / E2E of the whole system, or rather would you be looking for vulnerabilities in isolated services?
Well, this is actually a good question that I don't think I ever had a thought about that. But I think looking for isolation would probably be the first thing I would do. But yeah, I don't think I ever actually encountered like this situation before. It's actually a very interesting question. It's something that I would rather like research a bit more before giving an answer.
Okay, thank you so much.